Let's draw an example of a free body diagram using one of the problem illustrations in Sears and Zemansky's University Physics with Modern Physics by Friedman and Young. You can find this problem on page 164 in the 2012 edition. This diagram has one object only. However, there are two additional points in which the forces are acting. Let us label these as point A and point B, which are both on a rope. At point A, there are three forces present: F1 to the left, then tension 1 directed upwards supporting that point, and lastly tension 2, which is 45 degrees as shown. The goal of an FBD is to isolate each point in which the forces are applied so that we can make sense of their effect. Point A is in equilibrium, therefore the sum of forces here is 0. We can write this through a summation equation saying the sum of forces in the X is 0. What are these forces? These are F1 negative, and the other is the positive horizontal component of tension 2, which we label here as T sub 2x. From here, we can already see that F1 is equal to it. Through a quick inspection, T sub 2x is T2 cosine 45 degrees. Point A is also in equilibrium in the vertical, so we write the summation equation that the sum of forces in the Y is 0. These forces are T sub 1 positive and the vertical component of T sub 2. We write this as negative T sub 2y because it is directed downward. This gives us the equation that T sub 1 is equal to T sub 2 sine 45 degrees. We do not know yet the value of T sub 2, so we will just go back to it later on. Let's clear up the diagram so we can focus on point B. Tension here is the same as tension 2 at point, as since that is the same segment of rope. It pulls on point B in the direction shown. Applying transversal properties, this is also 45 degrees. Next is the weight value. There is no need to indicate the rope here as another tension, since it will just be equal to the weight. Finally, F sub 2. Point B is also in equilibrium, so the sum of forces in the horizontal and vertical are both 0. Let's write the summation equation for them here. What are these forces in the horizontal at point B? The first one is F sub 2, which is positive. For the sum to be 0, this is counted to the left by T sub 2 through its horizontal component, T sub 2x. In the y-axis, the forces are the weight, W, which is negative. This is counted by T sub 2 through its vertical component, T sub 2y, which is upward. This gives us the following equations. When combined with the equations at point A, we can simplify them further. Let's revisit the problem to check what is needed. Tension in the diagonal string is T sub 2, so we need to find its value. Then we also need to find the magnitude of F sub 1 and F sub 2. Based on the problem, the weight is 60.0 newtons. This will give us T sub 2. Which will lead us to F sub 1 and F sub 2. There we have arrived to the answer to the questions. However, is there a way to check if these answers are logical? Yes, there is. These values should have been the side of this right triangle here. If you are already an expert on FBD and equilibrium diagrams, you could have built the insight that you can do this shortcut. I hope you learned something from this video. Join me on TikTok and YouTube as we build more instructional materials for our students to improve their problem-solving skills.